Well, thank you so much for watching this video. We have with us Professor Simon Tröder, and I am Gabriel Gasque, Head of Outreach of Protocols.io. So this is a spotlight interview. And now I will hand it over to Simon for him to introduce himself.
Yeah, thank you very much, Gabriel, for having me actually here. So I'm the manager of the transgenic core at the CCAT at the University of Cologne. And we are basically working with CRISPR, so gene editing to generate mouse models, but also, as we will talk about today, reproductive technologies like IVF. Yeah, and I think basically this is the most important. These are the most important things, I guess. Yeah.
Thank you. And can you briefly explain what the protocol we'll be talking about is, and how you use it, and why it is relevant?
Yeah, so basically our protocol is about the cryopreservation of mouse sperm and the subsequent rederivation of such lines by IVF. And we call this protocol actually secure for simple and economic setup for rederivation. And I guess it's probably first important to understand why this is important. So as you know, a lot of researchers rely on mouse models to understand the mechanisms of disease, or, for example, right now to test the efficiency of vaccines against COVID, for example. But this comes also with the need for archiving and distribution of such lines. And with the archiving, I mean the long-term storage in liquid nitrogen, for example, and with distribution, I mean the sharing of such lines with other researchers around the world. And for this purpose, actually, sperm cryopreservation is ideal because it's very cost efficient and very easy, in contrast, for example, to embryo cryopreservation. But then you also need to rederive the lines by IVF, and this is a little bit more difficult. And this is actually what our protocol deals with mainly, is that we wanted to, or what we aimed for was an easily adaptable and cost-efficient IVF protocol to rederive such lines. And I guess we will talk about this later also in details, but so we were aiming for a cost-efficient and easy protocol, and also wanted to have this flexible to reflect the needs of a mouse IVF lab, which has to deal with sperm from different sources, like with fresh or frozen sperm. If you have frozen sperm, it can come from different protocols, and we wanted to accommodate those protocols, and also the mouse lines from different genetic backgrounds, because this is also sometimes a problem. So basically, this is what our protocol is about.
And so building on that answer, so why previous protocols didn't work for you? So why there was a need to optimize such a protocol?
Yeah, so basically, I think to understand that it's important to know that there are basically two IVF protocols. I'm saying now IVF protocols. What I mean is cryopreservation of sperm and IVF then subsequently. So for time's sake, I will call this IVF protocols. So there are basically two protocols around, and the one has been developed by Ostermeier and colleagues at the Jackson Laboratory, and the other one has been developed by the groups of Naomi Nakagata and Toru Takeo at CART, and the latter one is often referred to as the CART method or the CART protocol. So, and we were using the Ostermeier protocol for quite some time, very successfully for IVF, and I like this protocol. It's robust and simple. It's really great. The thing is that we realized that a specific strain, and that is actually the C57 Black 6 strain, doesn't work well with this protocol, or sometimes doesn't work well with this protocol. And this is not too surprising, because it has been known for quite some time that this strain is difficult to cryopreserve. Unfortunately, 90% of our models are in this strain, so there is a need for optimization. And at one point, we simply wanted to try the other protocol, the CART protocol, because there was some indication that it works better with this strain. But the problem with this protocol is that you have to buy very expensive media for this protocol. And I don't want to advertise the company now who sells it. I like this company a lot, I have to say. They sell very high quality products, and we use their products and are very happy with that. But we are doing a lot of IVF, and it was very expensive at one point. So we were looking for an alternative. And then we came across a protocol from the guys from MRC Harvard, and they actually outlined the preparation of the media. So they basically published all the components of the media which are needed there. So that was great. But the thing is, you can imagine for IVF, you need tiny amounts of media, and this media goes bad quickly. And so you have to generate tiny amounts of media, and then you need tiny amounts of salts, and you have to be very precise. So it's very difficult to produce high quality media for IVF. And so that was actually the point where I thought that there's room for optimization, actually just for us in the lab. And I started to think about this. And then I came up with basically what I thought is using a commercially available medium, IVF medium, and just which is cheap, and supplement that with the necessary components to make up the carbon media. That would be an optimization. And this is actually one main point of our protocol, which we actually optimize. So basically, our optimization, or the need for the optimization, was to establish a cheap IVF protocol, which is still efficient for the C57 Black 6 strain. And this is basically what was this was about.
And do you have any insights of how translatable this protocol is or would be for other mouse strains, or even beyond mice to other species, including humans?
Yeah, so to other species, I don't think one can use that for other species, because they are pretty different in this regard. Especially cryopreservation in mice is really specific to other animals, to other mammals, I would even have to say. But to other strains of mice, it is actually reproducible. So we have used this in other strains of mice, and it works actually very well in our hands. I should also emphasize, I mean, it is basically, the chemistry is the same as in the CARD protocol, and the CARD protocol has been used for other strains. So it's not too surprising that our protocol also works for other strains. But I mean, of course, you never know. But so from our experience, it works well in other strains.
Thank you. And what was the motivation once you had developed your protocol to have it peer-reviewed and published as an independent, formally peer-reviewed lab protocol in PLOS ONE?
Yeah, so in the beginning, I have to say, I didn't think about publishing that. I not on protocols, let alone peer review. That was never the thought. So the initial thought was really to optimize a protocol for our lab. But then I realized after a while, we had generated a lot of data. We had data from roughly 200 IVF, so it's a lot of data. And we realized that there is a significant difference between the two protocols. And that actually, I mean, there were, as I said, indications, but it has never been published that there is a clear and significant difference. And it's really clear, I have to say. So actually that I thought is interesting for the scientific community. That was one point. The other point was that you probably know that I have already published another protocol on Protocols.io and PLOS ONE. And this protocol was very well taken by the community. So I thought that was actually before this category lab protocol has been introduced. And when I saw that this new category had been introduced, I thought this is actually perfect for our data and our protocol, and that was very encouraging for us.
And how did the feedback that you received from the peer reviewers shape your protocol?
Yeah, well, so in this case, actually, we were fortunate that the feedback from all of the three reviewers was very constructive and very positive. So which is not always the case, as you know. So we didn't have to change much, but I have to say the suggestions of the reviewers really improved our manuscript, because I mean, it's always good to have another perspective. No? So maybe I mean I can share one point here. So one reviewer mentioned that we were still using conventional anesthetics in our protocol, and this reviewer suggested we may want to encourage people to use gaseous anesthetics, which are indeed better. And actually, we were even in the process during this time. We were in the process of changing to gaseous anesthetics, and I thought, well, I didn't put it in the protocol because I just simply didn't think about this. Huh? So, and then because of this thought from the reviewer, we changed this on protocols.io, and now we encourage people there also to use those gaseous anesthetics. So I think this is a good opportunity to thank the reviewers for their constructive criticism, because it was really helpful in this case.
And I mean, it's always good to have like supportive and critical, but supportive reviewers. And is there any other reason why you decided to make the peer review history public?
Yeah, I mean, in this case, it was of course easy, no? Because the feedback was so positive and constructive. But I mean, in general, I think that science should be as transparent and open as possible. I mean, especially in times like now. But also, I think it validates every study. If everybody can look up the peer review history and can see whether there is any controversy or any other opinions, maybe even on the manuscript, I think this validates the study. It should always be open. So for me, actually, in this case, it was very easy, but it's an easy decision because I think it should always be open.
And you mentioned that based on the reviewer feedback, you decided to incorporate or to change the anesthetic process during the protocol. I want to go deeper into that and ask you if there's anything that you tried that didn't work and didn't make it to the final version of the protocol. And the idea behind the question is, in many occasions, negative data never surfaces, and it is really difficult for people, for new people, to know what works and what didn't, especially what didn't or doesn't work. So is there anything that you tried that didn't work?
Yeah, exactly. I think this is a great question, because regarding negative data, I think I like to publish negative data if there are negative data. Actually, it happened for my last protocol that there was something which we tried and it simply never worked. It was very frustrating for us and it never worked. And therefore, I really wanted to publish this, and we did actually in the supplement. I really wanted to publish that other people do not have to make the same mistake over and over and over again. This is something which I found totally annoying. Huh? In this case, in this specific protocol, there were not really negative data in that sense. So nothing which really didn't work in a way. But what I can share here maybe is kind of like a dead-end thought process which I had. So I told you that what we did in the protocol is we took a commercially available medium and we supplemented that with some reagents to have the final fertilization medium. So okay, that's fine. There's another medium in the protocol which is important, and that is the sperm pre-incubation medium. It's actually called TYH. And I wanted to do the same with this medium. I wanted to find, because you can buy it, but it's very expensive. Yeah? And I wanted to do the same. So find a commercially available, cheaper solution which I can maybe just supplement to generate this media. But this was, I was absolutely unsuccessful. So I looked everywhere. I looked up all the available media or buffers or something like that of high quality, which I could supplement. I could not find anything which has the basis of this TYH medium, which I could maybe just supplement or something like that. So that was something which maybe somebody else will find it, and then I'm very happy if you tell me, but I was not able to find that. So yeah, I think it simply doesn't exist. So I think nobody else has to look for that. It doesn't exist.
And since publication, have you had to troubleshoot the protocol? And if so, why and how?
So since publication, troubleshoot, not really since the publication. We troubleshooted during the development of the protocol with something actually the same. It was along this line with this TYH media. We had to, so the composition of that is also published. And but it's the same problem with the fertilization media. If you have to generate such a small amount of medium and you have to use so many different components, tiny salt amounts and stuff like that, it's difficult. So even though the composition was published, it was difficult to generate. And what we thought then, so we have problems to do this. And what we thought is, what we can do is we can do the same as it has been done for other embryo culture media, to use frozen concentrated stocks to generate this sperm pre-incubation media. And this is actually now what we integrated into the protocol, to use concentrated stocks, which you can make up and freeze down for a long time, and then you can generate the media, this TYH media, rather easily, I hope. Yeah. So, but afterwards, I mean, yeah, well, troubleshoot, maybe we have probably optimized this protocol afterwards. It's not really troubleshoot, but there was one limitation which we also discussed in the paper. So we are depending on a proprietary media, where the fertilization media which we're using is dependent on the proprietary media where the composition is not disclosed. So this RVF media, so this is not disclosed, and this is of course annoying. And we are now in the process of using another medium, another fertilization medium as the basis, and this is called HTF. This is well known in the community, and the composition is disclosed, so everybody knows the composition, and it can be it's commercially available from different sources and also rather cheap. And we are using this media now, or we're testing this media now, whether one can also use that. And actually the data looks very promising, and I'm actually planning on updating the protocol, yeah, hopefully rather soon, as soon as the data is, as soon as we have all the data. And I want to update the protocol and also share the data maybe on Figshare or something like that with the community. And actually that's something, that's a good point, why I like this platform protocols IO a lot, because with the paper, it's very static, no? So the paper, the PLOS ONE paper, I cannot change. Yeah, I mean, this is okay. I mean, this has to be like that because it's a peer-reviewed paper. But on protocols.io, the protocol I can change now, and this has actually, it's the same as for my previous protocol. I think I've changed this protocol already, I think 2 or 3 times, because there were optimizations and there were changes within the community. There were new suggestions, and I incorporated them in my protocol. And now with protocols, I could share that with the community, those improvements, because otherwise, if it was just a paper, I could have not done this. So I think this is really great.
Yeah, and thank you for mentioning it, because what we want to do is to have this live versionable protocol, right? That evolves as you get feedback and as you reiterate the problem in your head and then execute it. And in addition to preparing the CTYH medium, are there any other critical steps in your protocol that people trying to implement it have to be really careful?
Yeah, I mean, as you said, that the media preparation is tricky, and one should really keep attention to the protocol and be careful. There are 2 other steps, I think, which are critical in the protocol, and one is the sperm pre-incubation. Because one should really keep to the time which is in the protocol. This is actually nothing which we invented. We relied on published data there, but you should really keep the time for the specific a source of the sperm which is indicated in the protocol, because it's different, for example, for frozen and fresh sperm. Yeah, so keep the time. If you extend the time or if you shorten the time, it will affect the fertilization capacity. So this is one point which is important, I guess. The other point which is important is the fertilization itself. I mean, it's easy to imagine, but it's so with fertilization, I mean the time point where the sperm and the eggs come together in the dish, basically. So this is a critical point because one should not disturb this process. As soon as you have this together, as soon as you start the fertilization, one should not open and close the incubator all the time, something like that. So it should really be in the incubator and left there. And maybe this is also not something which we invented, I have to say. So this is also coming from other people as well. And maybe there's something like a tip which I can share here. So we are using a specialized IVF incubator for that. You can also use conventional incubators, they work, and we have done this, it works fine. But the advantage of a specialized IVF incubator, if you have the budget for that, is that they have a very small, they are very small, and so they can restore the desired conditions very fast. And that is of advantage during this process. Another maybe little tip, which is also in the protocol, but I'm saying it again because it's critical here, is if you have the capacity, if it's possible, if you have an incubator where you can lower the O2 level, not the CO2 level, but the O2 level, so the oxygen level, this is of advantage. If you lower that to 5%, it's of advantage for the fertilization. Yeah, so it also works with atmospheric oxygen, but it's of advantage to lower the oxygen level.
It's more efficient.
It is more efficient. Actually, in our hands, it has also been published. It's a little bit controversial, in my opinion, but it's also in our hands. It works better with lower oxygen.
And would you like to tell us what is the significance, or has been the significance, of this lab protocol peer-reviewed article for your career?
Yeah, so actually, I mean, this is my first senior author paper, so I'm very excited about that. Actually, maybe I should mention I'm not a professor yet, so I mean, I have to say, I mean, I'm fully aware that this is not a groundbreaking new technique. So I'm not really expecting my career to change drastically because of this protocol, but that was never the aim. So the aim was really that I realized that this may be useful for other people, because it was very useful for us. Our IVFs work much better now, and it's much, much cheaper, I have to say. So the intention was more to really share this with the community, and yeah, that was the main intention, and not to change my career, I have to say. Yeah. Well,
congratulations on your first senior author paper. But I have to say, you know, I mean, now we do the spotlights. In the past, Protocols.io had a podcast series that was called Minor Tweak, Major Impact. And the idea is that, you know, science for the most part is incremental. And it is the small optimization steps that have a significance, right? Like you get a new groundbreaking technique every decade. Probably nowadays a little bit faster, but small changes that significantly optimize the result, I think, are very important. And the reason why our founder, Lenny Teitelman, created Protocols.io is because for a year and a half, he tried to reproduce in his lab, when he was a postdoc, a reported technique of single-cell microscopy, which had been extensively used in many cells. And I think that he wanted to do it in yeast. And there was something that had to be changed in comparison to other cells that have been imaged. And he spent a year and a half, you know, and the change was simple, but there was no knowledge about it, or there was no public knowledge about it. Probably other people try it and they probably troubleshoot it successfully, but those things, these minor changes are not reported, right?
Yeah.
Even if they are significant, because usually methods are relegated in the traditional peer review publication. So what I'm trying to say is that minor tweaks can have significant results and are important to share with the community, because they can save days, weeks, months of work for people out there.
Yeah, exactly. I mean, this was actually this was the reason why I shared this. I spent a lot of time for our lab to optimize it. It was a lot of work to dig through the literature and all this stuff. And in the end, I thought, if everybody else has to do that, it doesn't make any sense. So if I share the data, if I share my knowledge, if I share my protocol, maybe somebody else will benefit from that. And you're absolutely right. Maybe I'm mistaken, because with my last protocol, actually, maybe with my last protocol, there was the concern. Actually, we sent it before. We sent it to another journal, not PLOS ONE, but to another journal, and actually it was rejected because one of the reviewers, two of the reviewers were very positive. One reviewer said has no relevance. He said it's not. There's no optimization. It's very small, the optimization which we are doing. Actually, I thought, well, he may be right. It's really a small optimization. And then we sent it actually to PLOS ONE because one of our collaborators said, you know, that's absolutely not true. It's a great paper. And then now it's well taken by the community, and I got very, very good feedback from that. So apparently it's not so irrelevant as I thought. So it's sometimes, maybe I'm wrong. Maybe this
I believe that minor tweaks can have major impacts.
Yeah, absolutely.
Right? And it's very condition specific. It can be very strain specific. But if it helps somebody else, I think it's useful, right?
Absolutely.
And we're reaching the end of our time. But I wanted just to ask you a last question, which is there anything else that we haven't discussed, but you would like to mention at this point?
Yeah, actually, I think in the end, I really like to thank my team for all their effort, which they took. They really worked hard on this protocol. And especially Magdalena Wigger, who is the first author of the paper, she really worked hard on the manuscript, but also on protocols. The protocol there. Actually, I think I bothered her at some point a lot. She never complained, I have to say, but I wanted to have this perfect, and so. But she never complained. So I really have to thank my team. But I also want to thank the people who have been working on IVF protocols before our protocol. So the guys who made our protocol possible, right? Because without the guys from CART, and especially without the guys from MRC Habel, our protocol would not have been possible. So I really also would like to thank the guys from those people.
Well, thank you so much, Simon. It has been a really invigorating conversation, and hope to see updates to your protocol, and as well as new protocols in the platform. So enjoy the rest of your afternoon.
Thank you. You too.
Bye.
Bye-bye.